Good afternoon, everyone. Good
Yes, Mr.
afternoon.
Biwott. Mr. Biwott.
Yes, Bwana Ashira.
Nzuri sana. So I think tutawapea mpaka saa 8.
Oh, mpaka saa 8 eh?
Ndio waingie sasa. Because naona ndio wameanza kuingia. Because
Haya,
class ilikuwa
sawa.
ianze exactly saa 8.
Haya, sawa.
Okay.
generator. Then
If Mr. Biwott, you can start.
The generator has been stolen.
Sorry, I think so once again I was talking about what I wanted us to go through while we were marking your scripts. We noticed there is a huge gap that needs to be addressed, and it clearly came out that you could be having a problem with the topic oceans. I don't know, because it is too wide. Yes, I'm just confirming that I have unmuted. But again, it is difficult for me as a teacher to probably go to the oceans, but I need to build it. Hopefully, I'll be able to get time to take you through all the way to the oceans. But the process, as we talk about the hydrological cycle, you will realize that at some point we'll be able to mention about the oceans. Because if I think we also had that question that asked you to define the term hydrological cycle. And we were so particular on what we wanted you to tell us. We demanded you to tell us either it is the endless interchange or the continuous interchange of water from the oceans through evaporation to the atmosphere to form the clouds, to fall down as rainfall, to form the surface runoff, infiltration, the percolation, to get into the lakes, back again to the oceans. So you realize if you fail to tell us that it is a continuous, it is the endless, then possibly to us we'll feel like there is a missing link. And you will find that we will be penalizing you for that. So the key word here, and it should come out clearly, is it is the endless interchange. It is the endless interchange. So having said that, then there is also the other parts. The other part is, we and it is not only that we can ask you to define the term hydrological cycle, but at the same time we can give you the sketch of the processes involved in the hydrological cycle and ask you some of the key components. The hydrological cycle is composed of, I think probably I'll say, the four main processes. The first one is evaporation. We have to have this water in either of the water bodies. It could be a lake, it could be a sea, it could be an ocean. Then this water is heated to form vapor, then it evaporates, rises through evaporation, condenses in the higher altitudes to form the clouds, to fall down as precipitation. Now, once we have it in the form of precipitation, it could be in any of the forms of precipitation, and the most common one is the rainfall, as indicated there. Then this water can either infiltrate, and when you talk about infiltration, it is the zipping, entering the ground, or it runs through the surface through the process called the surface runoff. This water that infiltrates will recollect themselves within the pores, within the channels down there to form percolation. And as a result, this old water will find itself in a lake, it can also find itself in an ocean. So those key processes: evaporation, condensation, precipitation, infiltration, percolation, surface runoff, are extremely important. Not by mentioning, but at the same time, you being able to identify some of those processes in any of the sketches. The other question that we asked you, and quite a number of you struggled, is factors. I think we had that question that asked you factors that influence the surface runoff. Factors that influence the surface runoff. The same factors can still influence infiltration. Same factors can still influence infiltration. So we ask ourselves this question, and possibly for us again to engage the class, what are some of these factors that influence infiltration? Probably I can get some of you raising up your hands to explain to us some of the factors that influence either infiltration or surface runoff. I'm waiting for anyone to raise up his hand. Yes, I think I can see Samuel. Samuel, please. Yes, you've mentioned about the gradient of the slope, which I agree that it is a factor. But I'll be so interested in understanding how the gradient of the slope can be a factor, and then possibly how I want you to explain these points is how it influences either infiltration or how it influences percolation. I think I need someone to probably explain to us how the gradient can either influence infiltration or surface runoff. Admission 25, 26, 586. Admission 26, 586. You know, we are learning here. We are learning, and therefore we learn through our mistakes. It is by making mistakes that we are able to learn more. So don't fear to contribute in the discussions today, because by so doing, we are able to learn more. Now, we are talking of either this water infiltrating, and I've talked about the infiltration as the zipping through the pores of the soils down the earth's surface, or the water, it has rained. Then the water moves on the surface through the surface runoff. We are asking ourselves this question: how can that slope, as we've been told by Samuel, how can it influence infiltration? How can it influence the surface runoff. If the gradient is steep, then we will have more surface runoff compared to infiltration, because it gives this water limited time. It gives this water limited time to zip through the pores of the soil. So if the gradient is steep, then we'll have more water through the surface runoff. The reason being, it gives limited time for the water to enter through the pores, or to zip through the pores. If it is flat, or relatively, maybe I can say a plain, then the surface runoff is kind of limited, because we have the waters has all the time to go through, to zip through. I'll take the example of your field. Many a times when it rains, you will rarely see water stagnating. Maybe probably I'll talk about the rugby pitch, but many a times the soils around the bisons, around the hockey pitch, you will always find that after it rains, nearly all the waters uh, enters into the ground because of the terrain. If it is flat, then it goes down. Maybe I can say 70% of it will go down through infiltration. But if it was a steep, I'm trying to imagine one area in our school that has a steep, and I'm not finding any. But in a steep surface, nearly it's the other way around. We'll have 70% being the surface runoff and 30% infiltration. So that is a factor, and I think you should have considered that as a point. The other factor is presence or absence of vegetation cover. I said we are learning, and I want to see people contributing to that, to our discussions. How can the vegetation influence either infiltration or the surface runoff? Wambai? 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 Wayne?
Presence of vegetation, this means, let's say, for example, grass is going to hold that water that is flowing, thus allowing more infiltration rather than the surface runoff of the water.
Yeah, very good. I think there is. I need not to add anything. When we have vegetation, they kind of check the speed of this water that was moving at the surface runoff, and therefore, as it checks the speed, it allows more time. It allows more time to go through the root system down to maybe the interior of the earth, maybe huko ndani huko. So that is how vegetation can influence either infiltration. So where we have more vegetation, then it means that we have more infiltration. Where the land is bare, then expect it to have, maybe we'll have more surface runoff. Another, yes, thank you. The other factor that can influence either infiltration or percolation is the nature of the soil. And if you listen to me clearly, I used an example of maybe some section of your rugby pitch. And I also used the example of your soccer pitch. if you realize, and we've received high rainfall or even a heavy rainfall for that matter while we were in school, and you realize, and especially maybe one that lasts maybe for up to 3 or 4 days, you will realize, and I'm talking this in reference to the nature of the soil, you will realize that we will have stagnant water somewhere around the rugby pitch, whereas areas around the bisons, or maybe where we have our soccer pitch, or in any other area, you will find that there is, we will not have water. But where we have some section of the rugby pitch, we'll have some stagnant water. No, you ask yourself, why is that we have water there and in other places it doesn't have the water? So depending on the type of the soil, it will either determine whether the water is infiltrating or it is moving as a surface runoff. There are soils that get saturated very fast. An example of a soil that gets oversaturated within the shortest period is the clay soil. And if you are keen enough, you will realize that the type of a soil someplace around the rugby pitch, and I've seen it cracking most of the times. So that is an indication that the soil somewhere there is maybe a larger percentage clay soil, vis-a-vis around where we have the soccer pitch or any other place, because the soils there are the red volcanic soils, or the soils can be the loamy soils, which will allow water to infiltrate. It allows water to enter in. Yes, the clay soil will allow water, but at some point the soil gets oversaturated. You can even imagine an area where we have the sandy soil. You cannot even think of the soil getting oversaturated. For loamy soil, yes, after some time it will get oversaturated, but it will take quite some time. But for a sandy soil, believe me, nearly all the waters will find itself infiltrating. So we need to look at, I'm just trying to answer questions in two areas, and I'm just trying to touch on the infiltration, which influences percolation, and I'm also trying to probably open your minds on the surface runoff. Again, some human activities can also influence either infiltration or the surface runoff. You can imagine the Nairobi CBD or any other urban center where nearly all the areas have been, it has pavements or either it has the tarmacs, as compared to the rural areas where the soils are just left bare. So some of the human activities like pavements, like tarmacking, construction of probably buildings here and there, will reduce the amount of water that moves down through infiltration. Where we have a tarmac area, then the amount of water getting into tarmac road yenye inaingia huko ndani, I don't know hata kama inaweza fika 5% of all the waters that is poured in that tarmac road. Very little water will just get into it. So you see how human activities can at the same time influence infiltration. It can also influence the surface runoff. So depending on which process, which component, which process you are discussing on, then it becomes so easy to apply some of those concepts. So I said we are building on the our ultimate goal is just to take you through the water cycle, whether it is in the rivers, whether it is in the lakes. But I don't think we have a big problem in the lakes. Whether it is in the lakes, and I've said, or whether it is the water in the ocean, I think that is my primary focus for today. We want to discuss the action of water, the action of this river, the action of that wave in that ocean. Maybe to also help us through this area is when we are talking about rivers, then we need to be able to define some of the terms. These terms include a drainage basin. These terms include the river regime, river variation, rivers discharge, the river course, the confluence. Because in either way, if someone is just trying to introduce this topic to us, then believe me, they will ask by asking a definition of a term. And that will earn you about 2 marks. So you should be able to define some of those terms. Like, what is a river? I know, when we ask somebody what a river course is, or even I can ask a river, nobody does know what a river is. But I believe me, if I ask you that question in an exam room, then quite a number of you will get it wrong. Because yes, we may know what a river is, but getting words to describe a river, I don't know why some people quite find it difficult. So I may not really be able to take you through all the definitions, but I'm just trying to open up your minds that when we are introducing this term or this topic rivers, then we need to be able to define some of the terms. And I've said term number 1 is the river itself. Term number 2 is the river course, river basin, water divide, watershed, river discharge, river regime, confluence. So those words. So when we talk about what is the river basin is a portion on the earth's surface that contains the mainstream and its tributaries. In other words, we are talking about a section of the land in which this river and its tributaries is able to drain its waters, is able to get its waters. So the area at which a river A and its tributaries gets its water is what is referred to as the drainage basin. Watershed is the highest point between 2 basins. Probably I'll say that. If I use that example there, I am talking about this land, this highest point here that separates 2 drainage basins, in which this river draws its waters. We have this river A, if you can see my cursor, and we have river B somewhere here. This river B is getting its water through the tributaries from the same piece of land. So you will realize we have a high point here that separates these 2 rivers. So this high point that separates these 2 rivers is what is referred to as the divide, or what is referred to as a watershed. Another perfect example is this one. We have this drainage basin somewhere here. We have this river and its tributaries, and it is getting its waters from this high section here. We also have another river B that is flowing in this other direction, and the entire of this river system here is able to get its waters from this high end. So this highest point here is what is referred to as the watershed, or what is referred to as the water divide. The river regime is the seasonal variation in the amount of water. All of us, we've seen rivers when I'll use the example of River Nairobi River, that at some point you can possibly, I don't know whether it still qualifies to be called a river. At some point you may really categorize it as a stream, because the amount of water in that river for some period of time, you'd even question whether it is a river or it is a stream. But at the same time, you come after some time, you will find, the whole river channel is full to the brim. So that seasonal variation between today, the water is very high, the amount of water in the river channel is very high. What is that seasonal variation is what is called the river regime. The river's discharge is the amount of water that passes at a particular point. If you are standing at point B, the amount of water that is passing through that point, what is referred to as the river's discharge. Another key component, and I really want you to see it differently, is the long profile of a river. There was a time, and this should be your eye-opener, there was a time that we asked the current Form 4. I remember it was the map of Tambach, the one that you use in the end of term examination. And we asked them to describe the long profile of River Kerio. I know even if I ask that question right now, quite a number of you will struggle with that question. You realize these are questions that ask you your understanding of the long profile of a river. So by definition, we are talking about the section, the longitudinal section of a river from the source to the mouth, showing its shape, characteristics, maybe the characteristics and the shape of the river. That River Tana, from up there, Mount Kenya, all the way to the Indian Ocean, we are asking to, that is the long profile, that is the longitudinal section of a river. Then we will ask this question, and you will now be wondering, how will I be able to then interpret the map of Tambach in reference to the long profile of a river, named river, for example, River Kerio. So our understanding of the long profile of a river and the characteristics and even the features that are found within every section is very important. Now, I will take you through this, and I want you to, if you have time, to kindly copy that part that I've projected, because it will help you a great deal in answering any question that talks about the long profile of a river. The only thing probably I will ask you is, instead of saying the upper course, is you say the youthful stage. Instead of saying the middle course, you say mature stage, or rather you say the last stage is the old stage. So you avoid using the upper course, the middle course, and the lower course. Instead, you say the youthful stage, the middle course becomes mature stage, and the last course becomes the lower course. Kindly, I'm giving you like 3-4 minutes for you to write down those things. It is very important, and especially I have no problem if it is rivers, a question on rivers. But if it is a question that requires you to describe the long profile of River Kerio on MapWork, then you have to know that knowledge. My assumption is you are done. Now, the youthful stage. Whereas I have no problem with the characteristics of, the theoretical part of it, but I want to slightly drift to maps and map work and how you are able to identify. It's a very simple question that you only need to identify Sorry. We were talking about the long profile of a river, and I am particularly or deliberately trying to help you to answer a question comfortably in map work, and I'm referring you to in reference to a question that I told you we asked the Form 4s, and the performance was very poor. Now we are looking at the old stage, River Kerio in the map of Tambach is in the old stage. How do you tell that River Kerio is in the old stage? One, it's so evident that there is the wide meanders from the loops. It is so clear. Again, there is wide floodplain. Realize that there is very few, or in some instances, no settlements along River Kerio, some sections of River Kerio. That possibly tells us that the river floods in some occasions, in some periods. Number 3 is the low velocity. How do you tell that the water in the river flows in a low velocity? One, you can tell by the loops. You can tell by the width of the river channel. If you can remember, the thickness of the line, the thickness of the blue line, because that always indicates that there is a river, the line becomes a little bit thick. An indication, and at the same time, it is able to move in meanders. That tells you that the waters flow at a very low velocity. The other point is there is low gradient, and the evidence is the widely spacing of the contours. The contours are widely spaced. I looked at some and I realized, in fact, it was representing the lowest area of the lowest point in the area covered by the map. And if my memory served me right, I think it was around 1040. So that tells you that no, the gradient is very low. The spacing of the contours could be even up to, from that map, around 1.5 centimeters. So that is so wide, the widely spacing of the contours. You can also talk about the volume of water. There is the increased volume of water, and possibly you can still go back to the thickness of the line. You know, I'm not really teaching you on the long profile of a river, but I'm just trying to use the concept that we've already learned to see how we can apply it in other sections. Because quite a number of students, and even they asked me in class, mwalimu ni kama hujai tufunza hii. You know, but I asked them, we discussed the long profile of a river. But maybe I understood them that in the context of a map, then for some and for many, they had problems in maybe relating the concept that we learn in class and applying them in the in practical aspects of geography. Now is the processes of river erosion and the types. We have the processes of river erosion, and it includes solution, attrition, hydraulic action, abrasion. There was a time, I think I really can't remember the year, and it was a very serious exam. It was the predictor exam. And we asked students to explain the following process of river erosion. But in that exam, we really didn't tell them solution. We told them corrosion. And when they raised up their hand saying, I think this question has a problem. This question has a problem. It is very important for you to know that the names of those processes. If it is solution, it is corrosion. If it is abrasion, it is corrosion. So that A changes to O. And please kindly take note of that. Just but to emphasize, just but to emphasize on the processes solution, the emphasis lies at soluble dissolving to form solution. Attrition, the emphasis lies at collides, materials on transit, collides to reduce in size. Abrasion or corrosion, the emphasis lies, the materials acts as the scoring, the scorching on the riverbanks, the riverbed to erode. Under hydraulic action, again, it is very possible that we can ask you, explain hydraulic action as a process of river erosion. 4 marks. Back to you. Explain the process of hydraulic action. Explain hydraulic action as a process of river erosion. 4 marks. Someone to help me? Explain hydraulic action. Kuna mwenye anajiita you. Kindly you tell us how hydraulic process is a process of river erosion. Somebody else? Ryan? Think nimejipata tu kasa yangu iko hapo kwako. Ryan? Levin? Or Lavin? Okay. Under hydraulic action, and the question that I've asked you is, you are supposed to explain it, and the same process giving you 4 marks. How do you approach such a question? You realize that under hydraulic action, it is categorized into 2. The same one process is categorized into 2. It is either direct air action or 2, compressed air action. By explaining direct water action, you get your 2 marks. You explain compressed air action, you get your other 2 marks. So it makes 4. In some instances, again, that compressed air action can even earn you up to 3 or even 4 marks. So it is very possible we can even ask you explain hydraulic action, and you can see some crazy marks there. 5. You'll be wondering, Sasa, what will I write for me to earn these 5 marks? Now listen. I'll take the illustration of you taking a bucket of water outside your home where the soils are loosely held. You forcefully pour it on the ground. The impact of that water you are pouring on the ground, you will realize it is able to scoop the soil particles, it is able to carry. Oh, yes. You even call them painting in your language in school. You give a student a punishment to wash a corridor, na yeye tu anakuja kumwaga maji. While I appreciate the geography that yeye anatumia, lakini anatumia vibaya. So he pours water with the imagination that the impact of the water will carry the dust that is there, will carry maybe some papers that possibly is there. No, the impact of that water is able to carry the loosely held materials. The same thing applies in the direct water action. And as Ayala indicated, that we have the river regime, and I've said the seasonal variations. In some instances, I've looked at Nairobi River, maji ni kidogo sana, and I could even see some particles that to me can easily be transported or be eroded by those water, but because of the strength of that river zinakaa tu loosely held. Unapata hapo vibuyu, unapata nini, unapata carrier bags ziko hapo, but when it rains and we have we have water collecting itself in the river channel, it is able to erode. No, the impact of the water is able to carry. No, that is the point. So that impact of the water that is able to carry all the loosely held materials along the riverbank is what is referred to as the direct action. You will get your 2 marks. Now, the second one is the compressed air action. What do you need to write? We have the cracks that exist along the riverbanks. You'll possibly get a mark for saying that. As water flows through the river channel that has cracks, water and air both is forced into those cracks. Continuously, air and water will still be added. It's kind of pressure building. You add more water and air into a crack. The next day, you add water and air into a crack. By the time the whole week, pressure is building within the crack, because we have additional water, we have additional air. Over time, this pressure will be building within that crack until it will reach a point that we call in geography a point of pressure release. The point of pressure release, the water and the air within that crack goes beyond the elastic point. If you can use some physics term, I think, but it is long before I was in a physics class, but I can still remember that term. And because of the pressure release, it is so explosive. The entire section that had cracks explodes and finds itself in the river channel. So the process of attrition continues. You will get, I think, compressed action from many books, from many revision material that I've seen. It sometimes takes 2 marks. I don't know, more than 2 marks. It could be around 2, it could be around 3, or even in some instances, yes, I think between 2 and 3 marks. But you really shouldn't care on the amount of marks it carries. So long as you have those geographical facts, you've explained it the way it is, then it is upon them to see how they'll distribute the marks. If it is 4 marks, utapata tu kila kitu. So those are the types of, those are the processes of erosion. Now, we need to be very careful, and I have seen students confusing between the types and the processes. The types are as follows. We have 1, lateral erosion. What is the effect of lateral erosion? It is the erosion that takes place on the riverbanks. And the effect it has on the river channel is widening the riverbanks. So that is lateral erosion. Number 2 is vertical erosion. This is the type of erosion that is taking place on the riverbed. And the effect is the deepening of the river channel. That is the effect. We need to be able to tell us the type and the effect it has on the river channel. The down cutting, that is the effect, or the deepening of the riverbed. Lateral erosion, the widening of the river banks. The headward erosion is, no, this is a situation that I think is best explained in the river capture, whereby the the Pirate River, extends its length until it is able to eat back, or it is able to divert the waters of the victim river. So when you talk about the headward erosion, I think I'm saying that because it's not the first time that we are meeting this type of erosion. So it is the type of erosion that the river cuts back the upstream of the valley, and the effect it has is it is able to lengthen. It is able to increase the length of the river. If, for example, River Tana, when it started flowing from the spring, possibly I can say it was around 600, or maybe I can say 800 kilometers. After headward erosion, now we have a headward recession. The rivers eats backwards, and now the river possibly could have extended up to around 800, from 700 and something to around 800. You realize that the upstream is being cut back, and the river has lengthened its river course. We will have features that are formed as a result of erosion, but I'll probably pick two that I can even ask you to go and do some further studies. Besides the potholes, as you can see there, we have the waterfalls, the cataracts, the rapids, and the gorges. But I would really focus on two, that is the formation of a waterfall and the formation of a gorge. And the question, or the thing that is in my mind, is instances or circumstances that can lead to the formation of a gorge, circumstances or instances that can lead to the formation of a waterfall, and you can give maybe up to four. Think you will have done yourself a great justice. I like geography because it is able to clear some myth that exist in our villages. Back in our rural home, there existed a river. There existed a river that during the rainy season it could drown some people, some drunkards in the village. And I remember some instances where their bodies were never recovered. And there were a lot of myths until when I learned these geographical facts, I was able to understand. I could not understand, and I believe in those myths. They were saying they were Maginis, and I know you've heard them. But when I learned about these potholes, I imagined that if there are bodies of those drunkards that were drowned by water, or somebody slides akianguka tu akiteleza, you don't have to be drunk for you to drown. It's all about some bad luck. Anything can happen. So, and I'm just imagining that their bodies are trapped within those holes, as you can see there. Then we will be up and downs, creating some myths that are non-existential. So, but I understood that their bodies were kind of trapped in the porthole, and my understanding is it then will become quite impossible to retrieve their bodies. So I have said probably I will ask you that favor, that you kind of look at uh, the factors or circumstances that can lead to a waterfall, and number two, and each one of them you at least be able to explain four. I'm saying that with a big reason. Whoever will not do it, at some point will understand why I said you need to do that question. I am looking at my watch and I'm realizing that we have less than 8 minutes. My intention was really, but to really make it demystify, because we tested you on 2 occasions. We've tested on oceans. Very few students chose that question. We again tested you on rivers. The very few again that chose that question again performed dismally. So my intention was really but to take you through rivers, and at some point again be able to take you through action of waves, and especially the introduction where we had the densities, the introductory part of the oceans. My feeling is, from what we've tested, somehow, or maybe you still need time, but I think it became a little bit clearer to me that you did not understand those concepts very well. But we have the constraint of time. I can see a hand somewhere.
Yes, Mwalimu, I have a question.
Yes, please.
On the topic of lateral and vertical,
Yes.
could you kindly explain how the balance between vertical and lateral erosion changes along a river's profile?
Thank you. One, I appreciate that we are able to identify or to recognize the types of erosion as they are. and even being able to explain the effect of the headward erosion. When we talk about the vertical erosion and the impact it has on the long profile, when we talk about the vertical erosion, this is dominant in the youthful stage. And the effect it has is the creation of the V-shaped valley. I think I have it somewhere. Yeah. With the vertical erosion, the emphasis, we have the downcutting of the river channel. And the effect it has is one is it deepens, it downcuts the riverbed. And the impact it has on the long profile of a river is in the creation of the V-shaped river valley that is so clear and dominant in the youthful stage. So if you are talking about vertical erosion, it is very dominant in the youthful stage. Now, when you talk about the lateral erosion, you realize it is. Now, we talked about it occurs on the riverbanks. And the effect it has is the widening of the riverbanks to become a U shape. So the effect it has on the long profile is the opening of the river channel from a V shape, from the V shape until now, you can clearly see it is becoming a U shape. Pole pole. So this is a river that is in the mature stage. You can see some aspects of vertical erosion here that makes some kind of a V, but at the same time, because of the increased water, no, the topography is becoming a little bit gentler, so it becomes inaanza ku open up. So it still has both characteristics. Characteristics ya hapo juu, the youthful stage, but at the same time, ile characteristic yenye itakuwa kwa all stage, the opening up of the U shape itaanza kuonekana. So this is the effect on the long profile. The opening up of the no, not the the V-shaped river valleys. Thank you for that question. Any other question before we call it a day? Yes. HP 815.
Yes, Mwalimu, I was requesting if you could assist me with those notes.
Sorry?
I was requesting if you could assist me with those notes.
I will gladly do that. Maybe the only thing that you can do to me is I don't know if you can maybe you can just I don't know what now. How do I nitakujua aje ndio nikutumanishie sasa? I have no problem sharing, lakini which platform can I use? Because I think sia watu wanahitaji pia, but probably you can haya. I can share my email address, then I can share it to you. So the email is there. You can just inbox me and I'll share with you. Thank you. Somebody else? I want to really appreciate all of you for sparing up your afternoon. I was not able to make up for my class in the morning, but I thought it is also good for me to sacrifice my time to create, to maybe sacrifice my afternoon to help us. I am most grateful for the time we've had. See you next time. Thank you.